All right, let's review a few things on the study guide, starting with 1 through 3. It says we're going to classify each function as exponential growth or decay. To determine if it's growth or decay will depend on the value of your b. Your b value is attached to the exponent. So you want to look for that. It doesn't matter if there's something in front of it, you are looking for the x. Once you find the x, whatever you see attached to the x, that's your b. If the b value is less than 1, that means it's decay. If the b value is greater than 1, that means it's growth. So looking at number 1, you see the b value there is 1/4. Well, that means it's decay. Number 2, the b value is 7/2. Well, 7/2 is approximately 3.5. So that means it's greater than 1, which makes it growth. Number 3, look for your b value. It's this right here, the one that's attached to the x. 5, y'all, 5 is greater than 1, so that means this one is also growth. Looking at number 4 and number 5, you're going to graph each function using a table of values, and then you're going to identify what we call key characteristics. To do this, you want to go to y equals on your calculator and type in this function here. It would be best if you type it in without using the fraction bar option, and I'll show you what I'm talking about. Here is my calculator. When you go to y equals, if you'll notice right here, I've already taken the liberty of typing it in. You've got 1 divided by 2 to the power of x. So that's the one that I'm going to look at first and get the values on the table. Press second and graph. And here are the values I'm going to put in on my table. You want to put the ones that will fit on the graph. And I don't know, I can't remember if I put, yeah. So we're going to obviously start with the numbers that I'm giving you right here at -2. So let me move this over. -2 on the chart is at a +4. 0, oh, get away. 0 is at 1. And 1, I can move my screen over. There we go. 1 is at 0.5. 2 is at 0.25. 4 is at 0.0625. And then 5 is at 0.0313. So let's plot our points. Over -2 up 4. It's going to put me right here. That's 1, 2, 3, 4. And 0, 1 puts me here. 1 and then a half is going to put me right about here. And then I've got 4. Actually, I'm sorry, 2. And then a quarter of it. So that's close here. 4 is at approximately 0.025. Y'all, I'm trying to just keep as close as I can to the x-axis because all the values at this point are going to coast to 0 as if it's going to approach 0 but never touch, because that is where our asymptote is. As best as possible, try to draw your line. That shouldn't have went up. You're going to pretend like that line went down, like straight across. Yeah, I made it worse. All right, so now I'm going to answer the questions pertaining to growth decay. Well, for one, the value of your B is less than 1. But you can also look at the graph. The graph is declining. It's falling from left to right. So you know that that would have to be decay. Even if you didn't look at your value of B, the graph tells you that. My asymptote. This is where my graph is appearing to touch. Well, it's approaching, but it will never touch. Here at y equals 0. So my asymptote is at y equals 0. The domain of all the functions we are doing are going to be the same at all real numbers. My range is going to be above my asymptote. So if this is my asymptote right here at 0, the graph is above it. If the graph is above it, that means my range is greater than 0. Or you can write it in interval notation as 0, comma, infinity, close parenthesis. The y-intercept is where x is 0. X is 0 here. So my y-intercept is the ordered pair 0, comma 1. And number 5, again, type your fraction in as just division. So I've already typed it in. I need to go on this one and deselect it. Look at your table. And the values I need to chart at are at -2. Now, obviously, I see -2 is at 20. We are not going to be able to graph 20. We'll not go that high, but we will be able to graph a lot of the other coordinates. 0, 4, for example, that will be able to graph. And then 1 and 2.666 repeating. And then I've got 2 at 2.22, 2.07. Oh, I'm sorry, that's 0247. And then 5 is at 2.0082. I plot my points over -2 up to, oh no, sorry, up 20. That's way off the graph. So I won't be able to plot that one. I can plot -1, 8. Let me see if I can fit that on there. -1, 6, 8. Okay, there we go. And I've got 0, 4, 1, 2, 3, 4. 1 and then 2.6. So that's going to be past 2 right here. This one's like 2.22. 4 is like closer. We're getting closer and closer to 2, if you'll notice here. So notice getting closer to 2 gives me an asymptote of 2 because it appears that it is approaching 2, but I'm not going to touch it. Still crooked. Pretend that's straight. And again, our graph is falling from left to right, and the value of your B is also less than 1. So that tells you that you have decay. And your asymptote, we just said this, is at y equals 2. And I don't know if you remember, but I also told you that asymptote will always be this constant that's stuck on the end. So whatever you have for your value of your a times b to the power of x, whatever number you have adding or subtracting at the end is going to be your asymptote. My domain is all real numbers, and my range, if you notice, is above the asymptote again. So if it's above the asymptote, that means the range is greater than 2. Notice how these numbers are the same. Just like this one, those numbers were the same. The y-intercept is where x is 0, and x is 0 at 4. So 0, comma 4. And we'll start